Hello, in this video we are going to try to learn a polynomial function. So first of all we'll try to learn the definition of polynomial function. So let us see what is the definition of polynomial function. Definition. So by definition a polynomial function with n degree. So a polynomial function with n degree I can write down as function of x equals a n x power n plus a n minus 1 x power n minus 1 plus a n minus 2 x power n minus 2 plus, and there are lots of other term, plus a2 x power 2 plus a1 x power 1 plus a naught. So this is basically a general form of any polynomial function. Okay, now as an example, if I want to write a example of a polynomial function, so something like that. So let's say fx equals, let's say 2x power 4 plus 17x cube minus 4x square minus 8x plus 15. So this is what an example of a polynomial function, and as you might notice, in this case 2 is my an, n is here 4, so this example particular function n is 4, so it's what, a fourth degree polynomial function. So this is a fourth degree polynomial function, and as you can see, what is the other coefficient? 17, which is a n minus 1, and of course n minus 1 is x power 3, and so on and so forth, and 15 is what, my a naught, and a naught is what, the constant term. So if I want to write down for a polynomial function fx, this term which is a n x power n, so that means the term with highest power, so this term is called leading term. So what is the definition of a leading term? So definition of the leading term is a n x power n. So for this example, my leading term is what, 2x power 4. So for the example function, my leading term equals what, 2x power 4. All right, so because 4 is the highest power of x. All right, so out of that leading term, I have a called leading coefficient. So leading coefficient. So leading coefficient is an. All right, so for my example function, my leading coefficient is what, equal to 2. All right, so and the constant term, so the constant term of that function is what, a naught. okay, so the constant term is a naught, and for my example function my constant term is what, 15. Okay, so constant term is plus 15 for my example function. So this is basically a definition of any polynomial function, and from that definition we are seeing the leading term, leading coefficient, and also the constant term. All right, so now let us look at some properties of polynomial function. All right, so I'm going to present all the properties of polynomial function using graph, okay, or picture. So properties of polynomial function. Properties of polynomial function. So number one property is a polynomial function domain need to be, so domain of any polynomial function, domain of any polynomial function must need to be negative infinite to positive infinite. Okay, so that means your graph need to be basically spread infinite. So for example, if I put an example, this is my x-axis, this is my y-axis. All right, so if I draw a graph, so my graph, this side is going to the infinite, on the left hand side it is also going to the infinite. So this is basically a polynomial function because domain is what, from negative infinite to positive infinite. Now let us look at another function. Okay, another function, let's say I have a function starting from here and ending there. So you see my function have a starting point and ending point. That means what, domain is not starting from negative infinite and domain is not ending at positive infinite. So that means this is not a polynomial function. All right, so I hope you understand the domain. Okay, so domain of any polynomial function must need to be negative infinite to positive infinite. So this is the number one property of a polynomial function. Now let us see the second property. So second property of a polynomial function is that any polynomial function need to be continuous. Okay, so continuous curve. Continuous curve. All right, so let us see two example. All right, so in the first example let me draw a polynomial function. So this is x-axis, y-axis, and my polynomial function basically, so it is going towards infinity on this side, and it is going infinity towards the left hand side. So this function is what, continuous. All right, fine. So this is a polynomial function. Now let us look at another example. Now if you notice about this function, of course you know, left hand side going infinite, right hand side going infinite. So even though my domain is negative infinite to positive infinite, but what happened, you see this function is not continuous because there is a gap here. Okay, so this function cannot be a polynomial. So this is not a polynomial function. Okay, so this is not a polynomial function, and this curve is a polynomial function because a polynomial function need to be continuous. All right, so now let us see the last property. So number three property is that a polynomial function need to be with smooth curve. Okay, so smooth curve. Smooth curve. Now let us see using an example. So let me put two example. So this is my x and y axis. Now let's see. So you see this curve is smooth. Okay, so this is going to be a polynomial function. Now let us see another function. If I try to draw this function, all right, so let's see. Now for this particular function, as you can notice, this function domain is negative infinite to positive infinite. Okay, so the domain is negative infinite to positive infinite, so it satisfies my first property. Also this function is continuous. Okay, so it is continuous, but if you notice, I have a sharp corner here, I have a sharp corner here. So I know that if my function need to be a polynomial, my curve need to be smooth curve. So as you can see, this is smooth, no problem, this is smooth, but this is not smooth. Here I have sharp corner, so this is not smooth. So that means what? This function is not a polynomial. So this is not a polynomial function, this function is a polynomial function. So these are some properties of polynomial function in a graphical way. Okay, now let us look at identifying polynomial function using equation. So let us see an example. Let's say I was given two function. Function A is function of x equals 5x power 4 minus 2x plus 7, and I have another function B which is function gx equals 7x square minus x plus 1, and there is a limit on this function that x is less than or equal to 5 and x is greater than or equal to 1. Okay, so these are my two given functions. So what I need to do, I need to identify if these functions are polynomial or not. So first of all, let us see for this particular function, function A, my leading term is what? So my leading term is 5x power 4, because that is the highest power of x. Okay, so this is my leading term, and leading coefficient is 5, and this is what? A fourth degree polynomial, because n equal to 4, so it's a fourth degree polynomial function. Okay, so this will be actually a polynomial because it is satisfy everything. Now let us look at my this function gx. If you notice, this is a second degree polynomial because n equal to 2, so this n equal to 2, I am not going to say this is a polynomial function. But if you notice what I have, my graph is what? Extending from 1 to 5. So that means what is the domain of this particular function? Domain of this particular function is 1 to 5, and 5 is included, 1 is included. Now we know that for a polynomial function, the domain must need to be what? Negative infinite to positive infinite. That is the criteria for a function to be polynomial. For my current function, the domain is 1 to 5. So that means what? That means I can say the second function. So that means this function is not a polynomial function. So this is not a polynomial function, not a polynomial function. All right, so we can see the number a function is polynomial, this is not a polynomial function. Okay, so that's it is the introductory class for polynomial function. In the next video I'm going to discuss more about the section power function and other thing. Okay, so see you in the next